me. Now, properties of exponents, and this is, I know we've been working with quadratics, but as we know, quadratics have exponents. What's the highest exponent in a quadratic? 2, yep, because you have x squared. That's your highest exponent. Chapter 6, which is what we're going to be getting into more after break, is talking about polynomials. Now, quadratic is a polynomial, but we're going to be getting into ones that have higher degrees or higher exponents than a 2. So we're going to be looking at cubics, which the highest degree would be a 3, or quartics, which would be a 4. But before we get to that point, we have to review exponents and how they work together. So let's start with this expression, 2 cubed times 2 squared. And we're going to talk about what this means. Because exponents, all that exponents do is take numbers and rewrite them in a way that makes them easier to deal with. 2 cubed, I know that's 8, because that means 2 times 2 times 2, but we're going to write it out what that actually means. So 2 cubed means 2 times 2 times 2, right? And then 2 squared means 2 times 2. Okay, so how many 2's should I have listed then? 5. So you're going to write this out the way, or for what it actually means. 2 times 2 times 2 is 2 cubed, times 2 times 2. So we could then rewrite 2 times 2 times 2 times 2 times 2 as 2 to the 5th, because there's 5 2's. Now, properties of exponents allow us to go from here to here without doing all that in between work. So between the exponents 3 and 2, what did I do there to get the 5? What does it look like I did to them? Looks like I added 3 and 2 together to get the 5. That's one of your first properties here. It's called product of powers. You don't need to know the names of these. This is just like what the property is called. But product of powers means, product means you're multiplying. Powers is what this whole thing would be called. So when you're multiplying two things like that, you add the exponents. This should not look foreign to us. We spent a whole chapter and some on this in Algebra 1, so hopefully this doesn't look brand new. It shouldn't. This is the most common property we deal with. The other common one that we deal with looks like this. And we're going to kind of talk through what that means. 2 cubed means what again? 2 times 2 times 2. So I could write that as 2 times 2 times 2. And then what does that mean?
You multiply all the 2's in there by 2.
Yeah, you make 2 times 2 times 2 times itself, right?
Yeah.
So I would have 2 times 2 times 2 times itself. Everybody okay there? To go from there to there? So how many 2's do I have now? 6. So I could rewrite this as 2 to the 6. Again, the properties of exponents, the reason we learn properties of different functions is because it usually makes things shortcut for us so that we can just skip in between steps. So 2 cubed squared, what does it look like I did to the 3 and 2 there to get there? You multiplied. This is called a power on a power situation. And I say, like, if the exponents are right next to each other, that's when you multiply to get the final result. So we have a power of a power, is what that would be called. Power and exponent are used kind of together. They both kind of mean the same thing. So we're taking a power of a power already. Looks like this situation, where you have two exponents kind of right next to each other. And if you have that and need to simplify, you multiply the exponents together to get your result. Now, I could show you a similar kind of pattern for every one of these, but we're just going to list the next couple of them. You have a product of powers, you have a power of a power, you also have a power of a product. And that means if you're multiplying two different things and then that's raised to a power. Does anybody remember what we do with that power to simplify? Good. Yeah, distribute. Now, you've already done this in the class. We just kind of do it naturally without thinking about the property we're using, but this kind of reviewing the actual properties. Yeah, if you were multiplying, if this was like 2 times x squared, like we naturally square the 2, square the x to get 4x squared. So when you have a power outside parentheses like that, and inside the parentheses you have two different things, or more, we simplify by distributing that power through. Now again, you don't have to memorize the names of these, you just have to be able to use the properties. Okay. For number 4, let's go with quotient of powers. Quotient means what? Dividing, yes. So it's going to look similar to this one, except now we're going to be dividing. And, I mean, let's think through this logically. If up here, when I multiply two things with the same base, so like we had 2 cubed times 2 squared, to simplify we ended up adding. So when you multiply powers, you end up adding the exponents. So now if we're dividing, we're going to be subtracting the exponents. Good. So you can go either direction. You can go m minus n, so you can subtract the exponents that way. Or you can subtract them the other way. So we're combining these two things together by subtracting the exponents, either top exponent minus bottom or bottom exponent minus top. You can do it either way. All right, we have a power of a quotient. This is our next one. And that's if you're dividing two different things. So maybe this is like 2 divided by 3. And again, this is something that you've already been doing. We've already been doing like 3 halves squared. What is 3 halves squared? 9/4. So you just square the 3, square the 2 on the bottom, you get 9/4. So if we have a power outside some type of division or fraction, you still do the same thing. You simplify by distributing through. Okay, the last two, I kind of show you a different way. I'm going to show you up here on the board, I think. The best way to show you how this works is if we had a table. See that? Can you guys see it? This is to explain why the last two properties work before we actually cover them. Alright, this is my function, 2 to some anything raised to the 0 power is 1. There's not really a name for that. It's just understood that whenever you have something raised to the 0 power, it just becomes the value of 1. That could be x raised to the 0 power. That would still be 1. It doesn't have to be just a number. And then for number 7, when you have a negative exponent, what happens is that you flip it. And actually, I should make that not just a negative 1, but a variable, because it could just be a number. It could be negative 2 or negative 3. And that's what happens. You can have 2 raised to a negative power, and what that's going to do is it's going to flip and make a fraction. It can also go the other way, where you could have a negative exponent on the bottom, so 1 over a to the negative n, and then it'll flip it to the top. We call that a reciprocal property. Reciprocal is like the math term for flipping stuff from top to bottom or bottom to top. Okay, this again should not look foreign to us, but it's been a while since we specifically talked about it, so that's why we kind of review. We're going to play with some of these properties here and problems on the next page, but when I ask you to simplify an expression, what I'm asking for is that at the end of it, you have all positive exponents, and that your like terms have been combined. Now, when I say like terms, I use that term loosely, because like terms in this case is that if you have a fraction, you have x terms on the top and x terms on the bottom, you need to somehow get those together so you only have one x term. That's what I mean by that. Scientific notation, you can cross that off. We're not going to discuss that here. Alright, go ahead and flip, and we're going to do some problems. Make an a and a b for example 1. And then we'll again practice a little bit on the bottom there. Let's start with 4x squared y cubed raised to a power of 4. Okay, let's start out simple here. Now when you are simplifying expressions that look like this, I always tell you to start with the parentheses first. So if you're looking inside those parentheses, are there any like terms that we could combine together? No. You have a number 4, you have an x term, you have a y term. They're all different, so we can't combine. So then you look outside the parentheses, or what's directly attached to the outside of the parentheses, and that looks like an exponent of 4. What should I do with that 4? Anybody? Distribute it, and when I do that, I do have to multiply the exponents together. So what you have to be careful with is that when you distribute an exponent like this, you distribute it to each term inside the parentheses. So 4 to the 4th power. We can do that in our heads. 4 times 4 is 16. 16 times 4 is 64. 64 times 4. Oh, maybe we can't do that one there. Someone with a calculator. 64 times 4. 256. Alright, so 256. And then when we raise x squared to the 4th power, that's a power on a power situation. So what did we do before to simplify that? We multiply. So x squared raised to the 4th, you multiply those exponents together so you get x to the 8th. And then y cubed to the 4th would give me y to the 12th. And then you're done. Okay, not bad. Not bad. Alright, let's look at this one. We'll simplify this as much as we can. If there's parentheses, you always want to start with parentheses. Since we have no parentheses here, then you look for combining some like stuff together. Do I have some like terms?
Yes.
I have x cubed and I have x to the 5th. Now, this is not a power on a power situation. This is multiplying two different terms together, but they both have the same base. So when you multiply two things with the same base, what do you do with the exponent? You add them. Think of it like this is 3 x's. This is 5 x's. So how many total x's do I have? 8. So you can write that as 2 times x to the 8th. Now, with this negative exponent, to be completely simplified, you have to have all positive exponents. Whenever you have a negative exponent, you flip it. So we are going to take that y to the negative 2, and you are going to flip it to the bottom of this fraction, because technically this is over 1, right? So we can put this underneath 2x to the 8th and make it y squared. And when you flip, or when you perform that reciprocal property, it makes the exponent positive. And then you're done. Because you don't have any other like terms to combine, all your exponents are positive. You're golden. Let me try one on our own. And again, I review this, and everybody's kind of at a different spot with these problems usually, so if you're feeling like this is good stuff, that's good. Things are in place. But it's also why we review. Alright, let's go with we're increasing in difficulty levels here a little bit. Do we see any parentheses first? No. Usually that's where we start, but we don't have any parentheses. And then I would start by combining like terms. So if you have whole numbers, like we have the 4 and the 2, there's no exponents attached to that, right? You technically, like if you think of it as 3 separate parts, you have 4 over 2. What is 4 divided by 2?
2.
So we write that as a 2. Then the next part would be that x squared, y cubed, that part in the middle, and then your y terms. So you can deal with each one separately if you want. Makes it a little bit easier to deal with. The 4 over 2 would become 2 over 1, if you want to write it still as a fraction. And then the x squared over x cubed. Now we're dividing two things with the same base, so we would technically subtract the exponents. But you can also think of it as how many x's do I have on the top?
2.
How many x's do I have on the bottom?
3.
3. So how many would cancel?
2.
2. 2. And then you'd be left with 1 on the bottom. Okay? So you can take the 3 and subtract the 2 to get the x to the first on the bottom, or you can just think of as how many x's do I have, how many are to cancel, and how many are left. That's an easier way to think about it. So we have an x on the bottom, and then y to the negative 1 over y to the 4th. Now this one you can do a couple of different ways. You're still technically dividing two things with the same base, so you can subtract the exponent. You always want to subtract the lesser exponent from the greater, so that you have positive. So like here we subtracted 2 from the 3 to get x to the first. So what's 4 minus a negative 1? 5. Good, because if you subtract a negative, you end up adding. So we'd have y to the 5th on the bottom. The other way that you can look at it is if you automatically try to flip negative exponents. You could write it as y to the 4th times y to the 1st, right? Because that would flip to the bottom. And then would that still become y to the 5th? Yeah. So either way you think about it, your final answer should be that. 2 over x y to the 5th. Alright. Try this one on your own. Try it. Even if you're not sure you're doing it right, just attempt it. And obviously we're going to talk about it. Okay. What did I say? X, Y to the 4th? All over 2. Okay. Now there's a spot for C there, but we're gonna use that as a reminder problem next Monday. So go ahead and grab a whiteboard and marker rack. I'm gonna have you just practice a couple of these before we move on to the next